Another method for solving a system of linear equations is using the elimination or addition method. Now, just like the substitution method, my goal is to take this system of two equations and two unknowns and break it down into one equation, one unknown. And as the name applies, I'm going to be adding these equations together to do that. So notice that if I added the equations together right now as they are, I would end up with only one equation, but the problem is I still have two unknowns or two variables. So that means that I want to be able to create an equivalent system to the system that I have written there in a way that when I add them together, one of the variables is eliminated. So if you think about what that would take to do that, if I had terms in the equations that had opposite coefficients, such as 8x and negative 8x, when I add those terms together, I get 0. So my goal is to pick one of these variables and manipulate them through multiplication so that I end up with coefficients that are opposites of each other. So I can manipulate to either eliminate the x's or I can manipulate and eliminate the y variables. It doesn't matter which variable you choose to eliminate. Now, I typically look for something that'll make it a little bit easier. For example, if one coefficient is the multiple of another, then that makes the manipulation a little bit easier. Now, I don't have that here because for the x's, 3 is not a multiple of 2, and for the y's, 5 is not a multiple of 2. So the next thing I look for is that I need to have opposite signs. So if I already have opposite signs in place on one pair of coefficients, then I typically go after that variable to eliminate. So for my x's, my coefficients are both positive, but for my y's in this system, I do have opposite signs. The 2 is negative and the 5 is positive. So I'm going to choose, just for that reason only, to eliminate the y value. So now that I've chosen the variable or the variable term that I'm going to eliminate, now I need to get those coefficients to be opposites of one another. So that means multiplying the first equation in the system by a number that will give me a common multiple of 2 and 5. So the least common multiple for 2 and 5 is 10. So to get a negative 10 there as a coefficient on y, I'm going to have to multiply by 5. And then I'm going to multiply the second equation in the system by something that would give me that common multiple of 10 as the coefficient of y. So that would mean multiplying by 2. Now remember, just because I want to change that middle term, the y term in the equation, I have to multiply everything in the equation by the 5 and the 2 in order to keep the equations equivalent. So this is going to produce my new system of 15x minus 10y equals 40, and that's through just distributing this 5. And if I distribute the 2 through the second equation, I have an equivalent equation of 4x plus 10y is equal to negative 2. So remember, these two equations here are equivalent to the original two equations in the system. So I haven't changed anything. I'm still working with the same two lines. Now I can perform my addition. So if I add these two equations together now, I get 19x, and notice the y values have opposite coefficients. So negative 10 plus 10 would give me 0, so I do not have a y term in my sum. And I get 38 for my constant. So now I've got that single equation and a single unknown that I can solve for. So if I divide both sides by 19, I get x is equal to 2. Now remember that for solving a system, I need to find the value of all the variables in the original system. So since I've just found x, I still need to find y. So that means that I need to go back to one of the original equations in the system, or I can use one of those equivalent equations that I created. But typically the original equations have smaller numbers that make the arithmetic easier. So I typically go back and choose one of those original equations to find the other variable. So I'm just going to choose that first equation in the original system, 3x minus 2y equals 8. And I'm going to substitute that x equal to 2 into that equation and solve for y. So when I subtract that 6 from both sides, negative 2y would equal 2. So y is equal to negative 1. So that means that this system, those two lines intersect at the point 2, negative 1.